All right, guys, so let's jump into this. We're going to talk about matrices. Now, this is predominantly new. You've probably seen this representation somewhere, but you guys haven't done much with it, okay? So a matrix is a rectangular arrangement of numbers into rows and columns. Which way do rows go? Left to right or up and down? This is what catches everybody when you do this. Rows go left to right, columns go up and down. Only way that I'm ever able to remember that is, why do columns go up and down? Because columns hold up the roof, right? Think about old like Roman columns and stuff. They held up the roof, they went up and down. That's the easiest way I can think to remember them. And when we're looking at them, so this is matrix A down here. Matrix A has 2 rows and 3 columns. 2 rows this way, 3 columns up and down. Everybody good with that? Because we're starting real basic. So the dimensions of a matrix tell us the number of rows and columns of the matrix in that order. So since matrix A down here had 2 rows and 3 columns, we write its dimensions 2 by 3. Okay? Where in opposition to that, matrix B below has 3 rows and 2 columns. 3 rows, 2 columns. So you got to think that you're working left to right. You're going to hit the rows first before you climb up on top to see the columns. So the big thing you have to remember when we talk about dimensions of a matrix is it always, always, always rows by columns. And it's really easy to forget, okay? So it's always tall by length. Everybody okay with that? Good. And again, I'll share these slides with you, so if you don't get to write everything down as we're talking about them, do know that I'll present them digitally to you. So then this is a whole bunch of numbers inside this grid called a matrix. And now we're going to talk about matrix elements. So each matrix has a number of elements. So quick question. This matrix G that I show you, how many elements are in that matrix? How many numbers are in it? 9. Okay, and that's because what size matrix is that? It's a 3 by 3. So for rows times columns will also tell you how many entries should be in it. And then each one of those things, each one of those elements has an address. So for example, we're given matrix G, I want to find the element in G1, 2. Then when you go to do this, since rows come first, then columns, it's telling me to look into the second row and the first column and find the number. So when we look in the second row, that's the blue, and the first column right here, and we look for their intersection, we see that that number is 18. That's in the second row, first column. So the number that's in that location is the number 18. That's the element in the, did I type it backwards down here? I did. I told you this was beta. Fix it on the fly. In the second row, first column. Make sense? Well, let's go through and let's find a couple more. So real fast, on your piece of paper, just jot down what element or what number is in those positions, okay? guys ready? What's first one? So what row? Third row, second column, right? So which one's the third row, the top or the bottom? So third row and second column should give us the 4. First row, third should give us the -7. And then 3 and 3. So 3 and 3 gives us the 22. Now you could see, because we're talking ACT prep, they probably wouldn't ask you to just find one specific number. They may ask you to do something like that, to use those answers to do something. If you ask something like that, you'd find these elements first, and then we would just apply the operations. So third row, first column. Third row, first column is -20. First row, second, that's our 14. And now we're looking second to the third, that's 13. Are you okay with that, or am I going too fast? And something like that, we would just add those together. So this is -6. Did I kick the wrong number somewhere?
So it was like -13 to multiply that negative numbers.
Say it again.
So the last one was 13, right? But
Oh, but it's minus. Thank you. I see what you're saying. It was.
no, it's positive, but if it was minus, it would be positive, right?
Sorry, say it one more time.
Like G and then 2 and then 3, that's 13. But if that 13 was negative, it would be positive.
Yes, if it was negative, you were saying if it had been negative, it would be minus a negative. Yes. I thought that's what you were saying. I thought I had messed it up. But because it's not negative, it's just minus 13. And what if you're substituting in? It might be helpful to put parentheses around those specific numbers to help you keep track of that. So let's see, we've got -19. We put all those together because that's -20. I did these two first. 14 minus 13 is 1, and that'll take 1 away from that because it's negative. But they'll ask you to use something like that. All right, let's talk addition and subtraction, okay? Because now we're going to add these big matrices together. So you can find the sum of these things by adding the corresponding entries. So stuff in the same place, okay? Meaning that if I were to add A and B together, I would have to add entry in the first row, first column, with the entry in the first row, first column of the next matrix. And then so on and so forth. Same position, same elements, same position for each element gets added together. So it would look, you would write something like this. If I was going to add these two, so the first thing I would have is I would do the 4 plus the 1. Down here we would get 3 plus 5, 8 plus 0, 7 plus 2. So as long as it's in the same position, we can add them. And then you would simplify each spot. So 4 plus 1 is 5, 3 plus 5 is 8, 8 and 0 is 8, and then we get 9. It's like it's condensing a whole bunch of additions into a shorter notation, okay? Matrices get used a lot when there's multiple equations you want to solve. You want to do the same type of things to them. They get used in computers a bit. Let's practice one together that I don't have retyped. So first question. Let's think about what this is. What does this mean about the dimensions of matrices when we add them? So when I talk about dimensions, what are the dimensions of A? A is a 2 by 2 for the left side. The dimensions of B, this one was a 2 by 2. This one is a 2 by 2. This one right here that we're going to add, this is a 3 by 2, right? This one is a 3 by 2. Can I add those?
Yes.
Could I add together a matrix that is a 3 by 1 and a 3 by 2? Because what about, I have to have the same number of elements to complete the addition. You know what I'm saying? So they have to be the same size, both rows and columns, for us to perform the operation with it. We can't add two matrices that aren't the same dimensions, okay? So let's go through and take a minute, add that one up, okay? You probably get away with the matrices being printed, or probably just jumping to the answer, but just be careful. Thumbs up, thumbs down, good. You could probably, for some of these simple additions, especially if the matrices are printed out for you, which they should be so you can see them, you could probably get away without writing the middle step. 5 plus 2 is pretty straightforward. But I do caution you, sometimes they'll get more complex. We're going to learn some other operations. You might need to write some of the middle steps down as you get further, okay? But this would be right here, our final answer. So, ready to move forward? Subtraction. Subtraction and addition are the same operation. They always have been, okay? Meaning that when we do subtraction, we're going to do the same thing, but instead of adding the two elements, we're going to subtract them. So it works the same way. Stuff in the same position will get subtracted instead of added. So we could write this out that we're going to subtract these, but this means 2 minus the 5, 8 minus the 6, 0 minus the 11. Now with subtraction, you do need to be cautious and remember that order that you subtract in matters, okay? Because you can get some negatives in here. So 9 minus 3. So what's 2 minus 5? Negative 3. 8 minus 2? That's right, 8 minus 6. I just said the answer again. I do that all the time. 8 minus 6 is 2. 0 minus 11. Negative 11. And 9 minus 3 is 6. So it works the same way as addition, but you're going to subtract the elements this time instead of adding them. Let's see if we can answer this question now. What does that mean about the dimensions of matrices when you subtract them? Since they're the same type of operation as addition, that also means that the matrices must have the same dimensions. So the dimensions to be subtracted, this means they must be equal. They must be the same. If we can't take a 3 by 3 matrix and subtract a 2 by 3 matrix. We have to have the same number of elements in each one to make it work. And they need to be in the same positions as well. Practice one. You can probably go straight to the answer. Take a minute and we'll double check ourselves. figured we'd catch on to this pretty quick. It's a little bit daunting, kind of like complex numbers was when you first read it, until you realize it's a lot of the same type of operations. It works the same way. So biggest thing with this, just remember to subtract them. Remember the order matters. Take your time. It's a little bit new, okay? So now we're not going to talk about, well, we are going to technically talk about division because it is multiplying by a fraction, but we're going to talk about multiplication of matrices. Now, there's two different types of multiplication. The first one is called scalar multiplication. And this is the, I wouldn't say necessarily either one of them is hard, but this is the one that requires a little bit less work of us, okay? It's very much like addition, subtraction. It's probably something you can do without writing a bunch down to make sure you get the right answer. So there's two ways to deal with multiplication in matrices. First one's scalar multiplication. For this one, you see a single number in front of your matrix. This is telling us to multiply every term in that matrix by that value. It's almost like parentheses and distributing. That's what scalar multiplication kind of reminds you of. You're going to take this number and you're going to distribute it to every entry, every element of that matrix. So I'm going to start here with matrix A, and I want to find 2A, which is, that's 2 times the matrix A. Now, when you see that, it's a number, a single number and a matrix. What this says is we're going to take everything inside this matrix and we're going to multiply it by 2. So it's very similar to parentheses and distribution. So everything in there gets multiplied by 2. So we're still going to get a 2 by 2 matrix as our answer. That's going to remain the same. And we just need to compute each entry. 2 times 10 is 20. 2 times 4 is 8. 2 times 6 is 12. 2 times 3 is 6. That's all there is to it. This type of notation up here, when I wrote this for example, where they'll tell you matrix A and they'll list it off to the side, and then 2A, since A is a matrix, it means they don't have to write the matrix again. And it's a notation you should get used to because we'll list some matrices and ask you to do some operations with them. It might get repeated. It means that we can write the problem a little bit shorter and you can manipulate all of those things. Let's try this one with the negative. So what does this mean? 3b. It means negative 3 times all of this stuff. So we're going to take that negative 3 and we're going to distribute it to everything. So it's negative 3 times negative 4, negative 3 times 7, negative 3 times negative 2, negative 3 times 1. And then just simplify every entry. Negative 3 times negative 4 is positive 12. Negative 3 times negative 2 is 6. Negative 3 times 7 is negative 21. Negative 3 times 1 is negative 3. Those operations, I think, are pretty straightforward. They carry over from everything you've learned before, kind of dealing with equations. You just get more entries in a matrix that you've got to perform that operation to, okay? Now, you can use this notation and this idea of this. I want to talk kind of about division and what you would do. And we're going to approach that, the idea of solving matrix equations, okay? So what this says is I want to know the matrix A that I can multiply by 3 to get this output. What this really is this is a whole bunch of equations. This is like saying 3A equals 3 and asking you to solve it. Or 3A equals 24 and asking you to solve it. 3A equals 18 3a equals 0, and asking you to solve it. We don't want to write it out long ways, but what we'd say here is we want to find the matrix that would have to be there for A, because that's what we're solving for. If you just look at this one up here, 3a equals 3, what would you do to solve that for A? What's our step of algebra? You divide by 3, right? Now, have I taught you how to divide matrices yet? By number? No, that sounds interesting, right? But one thing you have to remember when you do division is also multiplication by that number's reciprocal, meaning that when we go to solve for A, we need to divide both sides by 3. That's the same as multiplying by a third. Any number I want to divide by, say I wanted to divide by 5. Well, that's the same as multiplying everything by 1/5. I wanted to divide by 20. That's the same as multiplying everything by 1/20. So I can do division with these things by treating it like multiplication. Because what I really want to do, figure out A, is I want to get this, I'm dividing the whole thing by 3, which is the same as multiplying it by a third. So the left side's just going to be A. How would I multiply that through? This is scalar multiplication. What this says is this 1/3 multiplies everything in this matrix to find the answer. You kind of see how I'm using the solving and the division in the same key here. So we would do that. What's a third of 3?
1.
1. What's a third of 24?
8.
What's a third of 18?
6.
6. What's a third of 0? Third of 0 is still 0, right? Third of nothing is nothing. So to deal with division, if you ever had a division, treat it like a multiplication of the reciprocal, and it'll work out for you, okay? So we've learned all the basic operations. Now there's one other that we had to deal with, because this multiplication that we learned right here, this was just multiplying one number by the whole thing. But what happens if I want to multiply 2 matrices? That's where things get a little bit different. And this will be one that we definitely want to spend some time with and kind of memorize, okay? So there's lots of blanks in here. Lots of covered material, I should say. So just kind of stick with me. So we're now ready to look at an example of matrix multiplication. So the other multiplication we called scalar multiplication. That was where we had just a number times the whole matrix. What we're going to do here with this matrix multiplication is we're going to multiply 2 matrices together. So I give you matrices A and B. We've got elements in them, same size. Now, to help understand how this works is we're going to take this and we're going to denote the rows and columns in them, okay? So for A, I only care about the rows in the first one. So this is row A1, this is row A2. So from our first one, when we work left to right, we're concerned about the rows in that one. For our second matrix, which was B from up here, we're not concerned about the rows. So what are we going to be concerned about? We're going to be concerned about the columns, okay? I'm going to denote everything in this column, B1, everything in this column right here, B2. Because what we need to do is, and there's a math term for this, which I'm not going to necessarily make you memorize, but it'll pay dividends later on. What we're actually doing is we're finding the dot product of these things, which doesn't make a lot of sense to you, but I'm going to show you how to do it. Because for us to find the answer to this, what we need to do for each entry is we need to multiply the row and the column of it, meaning this is how I find this first entry. And what I'll need to do is I need to multiply everything in this row by everything in this column. I need to find what's called the dot product of it. Okay, now because that doesn't make a lot of sense to you, we're going to talk about what we do to find that. Okay, so what are the two entries in row A1? They are the 1 and the 7. So the two entries in A1 are 1 and 7. What are the two entries in column B1? The first one is the 3 and the second one is the 5. So what we're going to do is we're going to multiply the stuff together that's in the same place. Meaning I'm going to take the 1, because we're doing multiplication. So I'm going to take the 1 and I'm going to multiply it by the 3. I'm going to take the 7 and I'm going to multiply it by the 5. And then I have to add those things together into one entry in that spot. Meaning, what is 1 times 3? 1 times 3 is 3. What is 7 times 5? 35. What is 5 plus 35? That's 40. So what happens is, in this answer matrix, which was C down here, the first term, the place in 1, 1 gets the number 40. Can you get it? It takes a little bit of practice. And for bigger matrices, obviously, this takes a little bit longer. So when you keep going down this, which row do you think I'm going to multiply for the top right up here? Is it still row A1 or is it row A2 now? And you got to think, each has a place, right? This is row 1 in my matrix, my new matrix. So therefore, I'm going to multiply row 1, but instead of multiplying it by column 1, I'm now in column 2. So to find this entry up here, I need to perform this same operation, but instead of having 3, 5 for my B, I now have 3, 2. So what I want you to do real fast, I want you to find that number that goes in that top one, okay? I got 17. Did anybody else get 17? We'll write it on another slide. So we want A1.B2. And we know that A1 is that 1 and that 7. But B2 is 3 and 2. We're going to go 1 times the 3, 7 times the 2. So 1 times 3 plus 7 times 2. 3 plus 14 tells me 17. Let's work the other ones, because we're going to do A2 times B1. Now think, this is the position in the new matrix. So in our new matrix C, this is element 2, 1. That's how we find it. We use the first matrix as our row and the second one as our column. It tells us which things to multiply. So A2 is the 2 and the 4. So this one is going to be 2 and 4. And this time we're going to multiply by the 3 and the 5 because we're in the first one. So we got to do 3 and 5. So that's 2 times 3 plus 4 times 5. So that's 6 plus 20. That one's 26. So that means this element is 26. Last one, 2 and 2. So this is C's position 2, 2. So we're going to go A2 and B2. So A2 was the 2 and the 4, and B2 was the 3 and the 2. So this is 2 times 3 plus 4 times 2. So that's 6 plus 32, which tells me that that entry, that element needs to be 38. It's a little bit confusing, but you're always going rows times columns. Everything in matrices is always rows and then columns, especially when you do this multiplication. Take that row and multiply it by all the columns. It's going to take a little bit of writing the first few times, just so you see it. I won't ask you to do a ton. I won't make you do like a 10 by 10 times a 10 by 10, because when they get bigger, you got to think that's a whole lot more multiplications and room to get lost, okay? And that's it for matrices. So I'm gonna turn off our recording here. I hope that there are some people here and you enjoyed that. Let's see. No, Pedro's still here. Hey, Pedro. I will post these things online. So if you have any other questions, I don't think I saw anything in the chat. Just let me know. We're logging off. Bye, guys. So you have to listen to me ramble sometimes on Mondays.